On March 28, 2025, Myanmar experienced one of its most devastating earthquakes in recent history, measuring a powerful 7.7 magnitude. The earthquake struck the eastern region of the country, causing massive destruction and loss of life. More than 2,000 people have been confirmed dead, with at least 3,900 others injured. Entire communities have been displaced, and infrastructure, including roads, bridges, and hospitals, has been severely damaged. Rescue efforts have been challenging due to blocked access routes and ongoing aftershocks. Countries such as Thailand, Laos, and Bangladesh also felt the tremors, with buildings swaying and residents rushing out in panic. Even distant cities in India and China reported mild shaking. The earthquake occurred along the Sagaing Fault, a major tectonic boundary where the Indo-Australian Plate and the Eurasian Plate interact. Experts believe the intense pressure built up along this fault line led to the sudden release of energy, resulting in the devastating quake. International relief organizations have stepped in to provide aid, with medical supplies, food, and shelter being distributed to affected areas. Governments worldwide have expressed their condolences, with some pledging financial assistance for recovery efforts. This earthquake has also reignited discussions about the potential links between seismic activity and deep-sea phenomena. While tectonic movements are the primary cause of earthquakes, some scientists believe that deep-sea geological processes could play a role in influencing seismic events. One area of interest is the presence of active volcanic eruptions beneath the ocean floor. The Earth's crust is not only active on land but also under the sea, where thousands of underwater volcanoes exist. Some of these volcanoes erupt without being noticed, while others cause disturbances that eventually manifest as seismic activity on land. Researchers have long studied the relationship between deep-sea volcanic eruptions and tectonic shifts, considering how the release of magma and pressure changes the stability of surrounding plates. The Indian Ocean, in particular, is home to numerous underwater volcanoes, some of which have shown increased activity in recent years. The 2018 Anak Krakatau eruption in Indonesia, for example, led to a massive underwater landslide that triggered a deadly tsunami, highlighting the dangers posed by deep-sea volcanic activity. Some experts speculate that similar underwater disturbances could have played a role in the Myanmar earthquake, although definitive evidence remains elusive. Adding to this mystery is the recent appearance of oarfish along the Andaman coast and the Bay of Bengal. Oarfish, known as the messenger of the deep, are rarely seen by humans as they typically inhabit deep ocean waters at depths of up to 1,000 meters. However, in the weeks leading up to the Myanmar earthquake, several reports of oarfish washing ashore have emerged. This has sparked speculation among locals and some scientists about whether these deep-sea creatures sensed seismic activity before it occurred. Some researchers believe that oarfish are highly sensitive to underwater pressure changes and electromagnetic signals caused by seismic activity. Historical accounts suggest that oarfish sightings have preceded major earthquakes in countries such as Japan, Mexico, and the Philippines. However, there is no conclusive scientific proof linking oarfish behavior to earthquakes. It remains a subject of debate, with some experts dismissing it as coincidence while others call for further investigation. Regardless of whether there is a direct connection, the mysterious behavior of deep-sea creatures continues to intrigue scientists and the public alike. The devastating earthquake in Myanmar has raised concerns about future seismic activity in the region. With the country sitting along the volatile Sagaing Fault, experts warn that aftershocks and potential secondary earthquakes could follow. Historical data suggests that large earthquakes in this region tend to occur in sequences, with major quakes followed by smaller tremors in the weeks or months afterward. As rescue operations continue, authorities are closely monitoring seismic data to determine the likelihood of further quakes. Meanwhile, discussions have intensified around the potential risks of an underwater landslide or tsunami. Myanmar's proximity to the Andaman Trench, a deep subduction zone in the Indian Ocean, makes it vulnerable to underwater seismic events. If an earthquake were to trigger an undersea landslide, it could displace massive amounts of water and generate destructive waves. Tsunamis originating from deep-sea seismic activity have historically caused widespread devastation, such as the 2004 Indian Ocean tsunami, which was triggered by a 9.1 magnitude earthquake off the coast of Sumatra. Fortunately, as of now, no significant tsunami waves have been reported following the Myanmar Quake, but experts remain on high alert for any changes in oceanic conditions. In recent years, advancements in satellite technology and artificial intelligence have enhanced the ability to monitor and predict seismic activity. Following the Myanmar earthquake, relief organizations have been using AI-powered tools to analyze satellite imagery and assess building damage in real time. This allows for quicker decision-making in allocating resources and directing rescue teams to the hardest-hit areas. Additionally, underwater monitoring systems have been deployed in various locations to detect signs of tectonic movement on the ocean floor. These systems use pressure sensors and hydrophones to pick up anomalies that may indicate potential seismic events. The integration of AI, satellite data, and deep-sea monitoring could significantly improve earthquake preparedness and response efforts in the future. Despite technological advancements, there remains a gap in understanding the interactions between deep-sea processes and seismic activity on land. One of the areas of interest is the potential role of deep-sea volcanic eruptions in influencing earthquakes. While most people associate volcanoes with visible eruptions on land, the majority of the Earth's volcanic activity actually takes place beneath the ocean. Underwater volcanoes are found along mid-ocean ridges, subduction zones, and volcanic arcs. Some of these volcanoes erupt quietly, releasing lava and gases that slowly reshape the ocean floor. Others can cause violent explosions, producing shockwaves that travel through the Earth's crust. Some researchers theorize that large-scale deep-sea eruptions could exert pressure on tectonic plates, potentially triggering seismic activity in regions like Myanmar. Although there is no direct evidence linking deep-sea volcanoes to the recent earthquake, ongoing studies aim to explore this possibility further. The mystery surrounding oarfish sightings continues to generate curiosity and speculation. While scientific skepticism remains, cultural beliefs in various parts of the world associate oarfish appearances with impending natural disasters. In Japan, oarfish are considered harbingers of earthquakes and tsunamis, with numerous accounts of these fish washing ashore before major seismic events. Similarly, in the Philippines, fishermen regard oarfish sightings as warnings from the sea, prompting communities to prepare for possible disasters. The recent discoveries of oarfish along the Andaman coast have fueled concerns among coastal communities, with some residents fearing that another large earthquake or tsunami may follow. Although scientists caution against jumping to conclusions, the phenomenon highlights the need for further research into how marine life responds to geological changes. The Myanmar earthquake serves as a stark reminder of the unpredictable nature of seismic activity and its far-reaching consequences. While human efforts to understand and mitigate the impact of earthquakes have advanced significantly, nature continues to surprise with its complex interactions between land, sea, and atmospheric conditions. As relief operations progress, attention is also being drawn to the long-term recovery and rebuilding process. The damage to infrastructure will take years to repair, and affected communities will require sustained support. Governments, aid organizations, and researchers are working together to develop strategies for making cities and towns more resilient to future earthquakes. Engineering solutions such as earthquake-resistant buildings, improved early warning systems, and better disaster preparedness programs are being emphasized as key measures for reducing casualties in future seismic events. The role of deep-sea phenomena in earthquake prediction remains an area of ongoing scientific inquiry. While oarfish sightings and deep-sea volcanic activity present intriguing possibilities, definitive proof of their connection to earthquakes has yet to be established. Researchers continue to explore how changes in the deep ocean environment might influence tectonic processes. One area of focus is the study of seismic waves traveling through the Earth's mantle and oceanic crust. Understanding how these waves interact with underwater geological structures could provide valuable insights into earthquake dynamics. Additionally, the deployment of deep-sea monitoring stations equipped with pressure sensors and acoustic technology may help detect subtle changes in oceanic conditions before major seismic events occur. As the world watches the aftermath of the Myanmar earthquake, the need for a multidisciplinary approach to disaster preparedness becomes clear. Collaboration between seismologists, oceanographers, climatologists, and engineers is essential for developing comprehensive strategies to minimize the impact of future earthquakes. Whether through advancements in technology, improved early warning systems, or deeper exploration of oceanic processes, the pursuit of knowledge remains crucial in safeguarding communities from the devastating forces of nature.